Hello people, welcome back to my channel. So hope you are enjoying the Python skill series so far. So in today's session, we'll be seeing about a specific function which is present in the NumPy library, and so it is very extensively used even with the pandas data frame, as well as whenever you want to conditionally add columns, or in case if you want to convert a numerical column into a categorical column. So for that we are introducing, or it's already there, but in this video I am specially uh, introducing about a function that is where, which is present in the NumPy library. So as I said, it is used for conditionally adding columns. So depending upon your numerical value, so if there are very large range of numbers, you basically convert it into categorical column, and so it becomes easier for you to distinguish. So let's see how it is done. So first case is like you want to convert some numerical column into categorical column. So for this we are again using the OLA rights data set that we have. So uh, this is our code. So what I do is I'll just run this. So, and if I do a df, then you can see the different columns which it has. Now what I'm doing is if you observe this miles column, that is this one, so it contains all different numerical values, so all real valued which are in floating point. So now what I want to do is I just want to convert this particular column into a categorical column. So basically how will I do that? So for to conditionally add columns into this particular data frame, we have a special method which resides inside the NumPy library, that is called as where method. So this is the syntax of how the where method is used. So first this thing what you can see, that is the new column that you want to put. So I've named it as miles cad, that means miles category, and this is how the syntax of np.where looks like. So it is a np.where built-in function, and so it is mainly applied to the numerical column. So now what I'm doing is I'm just classifying into two categories, that is if the values in miles column, if they are greater than 5, that means uh, it will be a long drive, or else if it's not, then it will be categorized as short drive. So this you can like remember, it has the same syntax like the if else statement that we have seen. So it works in the similar way, but with data frames you hardly use this if else, but mostly you go with np.where. So that has the same functionality. So in the data frame, on the fly itself, it will add a new column. So, and if I run this, and if I check the data frame, and you can see like here you get the miles category. So this value, that is 5.1, is greater than 5, so it is categorized as long drive. This is 5, so that is short drive. Since because we have kept everything which is greater than 5, it will be categorized as long drive. Else whatever is lower, so this value is lower, so that is short drive. So you can see all the other values. So it has conditionally added a new column into your original data frame. So this was regarding like uh, putting into two different classes. So now this particular column, which was earlier a numerical attribute or numerical column, has been converted to a categorical column. So this is where some kind of techniques for easy accessing of the data can be used. So now this can be considered as a binary valued column, or this can be considered as class, a new class which you are dynamically adding to your data frame. And so what if I want to add a multi-class to this? Now to this, what I need is, my requirement is, I want one more value. So I want long drive, intermediate drive, and short drive. So for that, what we have is, uh, we have converting into three more categories. So before that, this will give you the count. So long drive is, you have 643 in numbers, and short drive is 513. So all the values which were converted, that was to integer 64, that is this one. So next, our use case is like, we want to categorize into three more categories. So it will be like, miles which are greater than 10, it will be categorized as long drive, and miles which lies in between 5 and in between 10 will be categorized as intermediate drive, and miles which are less than 5 will be categorized as short drive. So there are two techniques or two approaches by which you can do this. So first technique is the way by which you can use the np.select. So np.select is basically like your uh, selection operation which is there in DBMS. So it works in the similar way. So it is very simple. So first what you do is, you create rules. So these are the given rules which you have, or into this categories you want to put. So accordingly, what you do is, you create a list of tuples. So that I name it as rules, and to this I am putting like df of miles for this particular column which I have. If that value is greater than 10, so that is one condition. So here I am putting all the conditions, and if the df of miles is greater than equal to 5, and df of miles is less than 10, so that is second rule, and third rule is df of miles is less than 5. So uh, corresponding to our three requirements, we have three different rules here. So that will be kept in one list. So it basically contains tuples. So that is a list of tuples. Next, we have this category. So in category, I have three categories. So L stands for long drive, M stands for medium or intermediate. So I'll just put it as I, and then short. And then what I do is, this is my new column in the data frame, that is L slash I slash S. So to which we are applying a select method. So to select method, you are basically passing the first list, that is rules, and second list, that is category. So how it basically works is, it will uh, when you execute this particular data frame, it will first check the rules, and so it will directly go to the miles column. It will sequentially check whether each of the value satisfies which of the condition, and accordingly it will go to the category, and then it will classify accordingly. So this first value will correspond to the first letter here. The second rule corresponds to the second letter here, and the third rule corresponds to the third letter here. So this is how this basically works. So it works in a one-to-one fashion. So now if I run this, and if I see df of head, you can observe that is the final column, that is lis. Now it has been categorized into I and S, L, like this. So this is also one way, like where you want to convert a numeric column into multi-class. So now this is a multi-class. Earlier what we did was a two-class column. So whatever value, like 5.1 lies in between 5 and 10, so that is categorized as intermediate. 5 which lies in 5 and 10, that is intermediate. 4.8 less than 5, that is short. 4.7 similarly short. 63.7 that is more than 10, that is long drive. So this is one way you can do by the help of list. Now what we love to do is instead of doing all these things like creating two lists and then applying the select function, we can simply use the np.where. So that is a simple one liner. Just be careful like when you implement this or write this code. So let's see what is the second technique to this. So watch here carefully. So we are just putting this df, that is our new column that we want to add in our data frame, and to this we are again passing the np.where. So np.where takes the first condition, so this is the first condition, and to this the value. So if this condition is satisfied, it will get this particular value, that is immediate next value. And the second else part is this thing. So else the first condition is not satisfied, it will jump over to here, and in this we are putting again a np.where, and inside np.where we are again doing the comparison, or we are comparing the relational operator. If it is less than 5, it will be categorized as short, else it will be medium. So we are not putting this particular condition. So it is up to you. If you can modify this particular code, you can do it, but this is the simplest way that you can do. So this is nothing but a nesting of np.where. So np.where inside a np.where, this is a one liner. So if I run this, you get the same output. So here this was the output of the previous run that we did here, this for this snippet, and for this snippet we have lms. So that is just for uh, easy understanding, like when I run this you get this. So that is same thing, instead of letter I am putting m. So that makes the thing simpler. So it does the same kind of categorization as with you create with the technique one. So well, that was all regarding a brief introduction about a very useful method which is most widely used in data science for pandas as well. So this goes hand in hand with the pandas data frame, that is about the np.where method. So hope you guys enjoyed this video. If you found you got educated about this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.